Hello, and a very good evening to everyone. Today we are going to start a new chapter, the Earth, and this is the second chapter of Air Navigation series. In this, we'll study compression ratio, latitude, longitude. After that, we'll study the Great Circle Rhumb Line, and I'll also make a part 2 of the video in which we'll study the departure and all the important questions about it. So, the first question that comes about Earth is what is shape of the Earth? So in my childhood, I studied that Earth is like a potato, irregular shape, no smooth surfaces, all bumpy. Then I started studying air navigation, and then R.K. Bali sir said it's like a pear, like a little squeezed from the top and expanded from the bottom in the southern hemisphere. Then I studied Oxford air navigation. They said it's an oblate spheroid. So they all have decided that they will make onion potatoes of the earth. So what we are going to take it as? So right now in this chapter, earth is taken as an oblate spheroid. Oblate means that something that's compressed from top and bottom, expanded from sidewards, and spheroid, it means a shape like a sphere. It looks like this. The black marking, it is expanded from sides. This is oblate spheroid. So now that we see that Earth is compressed from top and bottom, we also need to study the compression ratio of it so that we have an idea and estimate that how much compression is there. So let's write down the values first. So 12,713 kilometers is the polar diameter and 12,756 kilometers is the equatorial diameters. These are the value that's common in R.K. Bali sir's air navigation book and also used by ICAO in its WGS 84, a mathematical form of Earth that's designed by computers. So this is the diameters that's used in it. So the value is taken from there. Using these values, if we put it in the formula, we'll get the compression ratio of Earth. So let's quickly do it. So the first value comes 1 upon 297 and we round it off. That becomes 1 upon 300. So let's quickly understand what is this 1 upon 300. So let's imagine this is our Earth. So now we will imagine the diameter, the equatorial diameter is 300 kilometers only. As we see, it's much more, 12,000 and some kilometer. But let's imagine for once it's 300 kilometers, the equatorial diameter. This 1 upon 300 says that the polar diameter, this will be 1 kilometer less. So if equatorial is 300, the polar will be 299 kilometers only. It's that simple. That is the meaning of this ratio. So this is all about compression ratio. Now we'll proceed to latitude and longitude. So the definition that again we learned in the childhood was so simple that imaginary lines running north, south, east, west, and which tells our positions, that is latitude and longitude. But here if you see, this is a much different definition and this is the more accurate definition. That's why we need to study this. So what it says, it is the angle subtended at the center of the earth by the meridian joining the equator and the point at which we are. So we read this, we may have understood it, may have not. So how to put it in simple? So we'll do a quick example. This is our earth. Let's take any point in it. Let's say Madrid. Okay. It is right above Morocco and Algeria. So according to this definition, what will be its latitude? So the shorter arc of meridian joining equator to the point. Let's draw this. Joining the point to the equator. This is the equator. This is the point, and this is the shorter arc. So the angle subtended by this arc at the center of the earth, this will be the latitude of this point. So now to imagine it one step better, why not do a new experiment? This is earth cut in half, and now we'll actually study the angle. So I've cut it exactly from this place. Where is it? Yeah, Madrid. So what will be the angle that will be subtended at the center? So this is the equator, the red band. This is Madrid, and this is the angle that's subtended at the center. You know, this angle is the latitude of Madrid. It's that simple. And one more thing, shorter arc. Why shorter arc? So if you see in this cube, this is one arc. There is one more arc possible that's going all around the earth and coming back at this point. So that we do not take this longer route. That's why it's also mentioned shorter arc. That's the significance of this. This is all about latitude. Now coming to longitude, very similar explanation to it, but only the difference is that equator, arc of equator joining prime meridian to the point. So again, let's take it. Let's say we are in Srinagar. Okay. Now it says shorter arc of equator joining prime meridian to the point. This is the equator, and this is the prime meridian passing through London. This dashed line is prime meridian. I'll erase other things. Yeah, so prime meridian, this is Srinagar, this is equator. Now one issue is there, shorter arc of equator. Our point is not on the equator, so how to take the shorter arc? Do we have to take the arc of latitude? Never. We always have to take the arc of equator only. How we will do that? We'll just draw a straight line joining the point to the equator. This. We will not calculate the angle subtended by the arc of the latitude. This latitude. No. We'll take the equator only, and to get that, we'll draw one imaginary meridian through this. And this is the arc of the equator. The angle subtended by this arc on the center, that will be the longitude of this. So that's the understanding of it. Now, sometimes we get confused. I also get confused on which one was longitude, which one was latitude. So I'll tell you one trick that my teacher taught me. जो लेटे हुए वो latitude, जो बच गया वो longitude. So you can use this to actually avoid the confusion of which one was longitude, because in pressure you may even forget it. So remember, जो लेटे हुए lines हैं, the lines which are lying down, they are called latitude. So this is about latitude and longitude. Please copy it down, then we'll proceed to the great circle and rhumb line. So I hope you have noted it down, and before we proceed to great circle and rhumb line, let's also complete the coordinate system and how it uses latitude and longitudes to describe any position on Earth. So I'll erase it now. So we learned two things now. First, how to use it, and second, why to use it. So we all have been using Google Maps, and we all must have had some experience with Google Maps. It is a very good example of studying the coordinate system. How? Wherever you place a pin on Google Map, it will give you a line of longitude and a line of latitude. Very precise. This degrees, this minute, this seconds. What's its significance? those two lines that Google is giving, which is the latitude and longitude, tells the exact position of yours in the very fine grid that's made by computers. Let me give you a quick example. This is the coordinate of place in New Delhi. You could directly put this in Google Maps and it will give you the location of Palam metro station. So it's quite fun. You could locate anything using these coordinates, maybe your friend's place, and someone needs to give you a location at which they live, and they need to tell 10 different things like turn left from here, turn right from there. Instead, they could give just one number, and if you put it in Google Maps, click on directions, it will give you every direction that you need to take to reach there. That makes it so easy. Similarly, for aircrafts, now we will later on study INS, Inertial Navigation System. In that, you put these coordinates, initial coordinates, and using the accelerometers, it tells your final coordinates, where you are present. And all of these is dealt with north, east, south, or west, and that all coordinates give you a pinpointed location. Very easy to navigate using that. Let's quickly understand a few basics just for clarification. Anything north of equator represented with north, and south represented with south. There is 90-degree north, 90-degree south limit above and below. If we see east and west of prime meridian, there is 180-degree limit. So you can go 180-degree east or 180-degree west of the prime meridian. So this gives you a limit. One second. This gives you a limit for what is the maximum range you can go using these coordinates. And beyond, if 180 east, if you go beyond this, you will finally enter 180 west only. Somewhere in that range, maybe 179 west, 178 west. So this is the basic numbers up to which we can go. This is how we express it for someone who wants to understand what is this dash and double dash. So it's minutes and seconds. So that we can express 1 degree into even more accurate terms, someone invented minutes and seconds. So this is all about coordinate system. Using this, we can find out our position. And please note it down. तो मिटा दिया जाए. So let's begin the great circle. What is the first thing that comes to mind when we hear this term great circle? कोई महान circle होगा, something very great. So what's so great about it? Well, it is the biggest circle that could be drawn on the surface of the Earth, and that divides Earth into two equal hemispheres. When I was asked this question to let's guess what is great circle, I guess that it may be the equator because it is a very big circle and it's dividing Earth in two equal halves. But that's not it. It could be any circle drawn on the surface of the Earth at any angle. Only requirement, it should divide Earth into two equal halves. Now, why do we need to learn it? Why do we need to learn about circles drawn on Earth? So the reason is it gives the shortest distance between any 2 points on Earth. That's its significance. And we are gonna fly aircrafts. So we need to know now that when we want to go from one point to another, what is the shortest route? Let me give you a quick example on the globe. So we are going from Dubai to Washington, and I already made a line on it, which is joining these 2 points. The solid line from Dubai here to Washington here. This is an arc of a great circle, and I extended it like this, to make a great circle. Now this has two properties. First, it is the shortest distance, and second, it will automatically divide Earth into two equal halves. So that's how it works. Now, few countries may feel like sometimes there is problems going on beneath few countries, like there are wars. So we need to avoid few areas, and in that situation, few countries choose to fly longer routes to avoid all the dangers by war. But we are Indian pilots, ना? हम इंडियन पायलट्स को कहाँ फर्क पड़ता है कि नीचे वॉर चल रहा है, क्या चल रहा है? This is an example. Here India 1-1 flying right above Russia during Russia-Ukraine war. क्योंकि हम लोग को तो तेल बचाना है, वॉर चल रहा है वो तो उनका दिक्कत है. So this is how great circle works. It gives us the shortest distance. Now let's write few properties about it. Then we can proceed to understand the meaning of those properties. So these are the 5 properties about it. The last 2 are very basic or simple, but the first 3 are important to remember. First, gives the shortest distance between any 2 points. That's the most important and most practical reason why we study great circle. Second, only one great circle can pass through 2 different points until the points are diametrically opposite. So this is a bit important to understand what this means. So generally, if any 2 points are formed little close to each other or just not diametrically opposite, only one great circle can pass, like I made on the globe, Dubai to Washington, the 2 points, Dubai and Washington. But if I took 2 diametrically opposite points, like say this, the North Pole, and second point, the South Pole. So if these were my 2 points, infinite number of great circles could have passed through it. For example, the meridians. The meridians pass through both of them, and the anti-meridian returns. So this is also a great circle. Like this, infinite number of circles could have been formed. So this is the meaning of the second point. Third, radio waves follow great circle path. So what are radio waves? General radio waves are those which is used in our equipment, navigation equipment, or for communication. So the radio waves are like normal electromagnetic waves. They travel straight, and that's why these also follow the great circle path. There is one thing important in this. This definition comes in use in one very exceptional question. In that, it's given, later on it will come, not now. A navigation aid is given, such as VOR, and then deviation or variation is given, and then they ask what will be the reading in the aircraft. In that, this becomes important because VOR uses radio waves. So remember this definition for later on. This is going to come into use. Now, I had a doubt while studying this thing. Radio waves are electromagnetic waves. We all studied in 12th that it travels straight, completely straight. So I thought, let's say I'm in New Delhi and I release the radio wave. After traveling a bit, it will go into space because Earth is round and radio waves travel in straight lines. So it will go like this into space. How is it traveling on the Great Circle path? So the answer is the radio waves only follow the Great Circle path at the distance they can reach, like the horizon, not beyond that. There is one more exception in this, that HF waves, which is a band in radio waves, they also bounce back from the ionosphere, and like that bouncing back could make it reach even farther, even beyond horizon. So two exceptions that you could keep in mind to avoid getting confused. Then last two, very simple, looks like a straight line on Earth's surface. So if I'm in India and let's say there is Washington right ahead of me. So if I draw a great circle path, it will look like a straight line for me. I will have to walk just straight to reach Washington. It's as simple as that. It means that we do not need to curve or something like that. Fourth, it has the same radius as of Earth, also the same center. So obviously it's the biggest circle made on Earth. So obviously the radius and the center would also coincide with that of Earth. One new thing that's beyond these points that you may notice, it will also come into use later. Let's see the route again, Dubai to Washington. Initially when we started, our heading was this. So if we have a compass, it will show we are facing somewhere around, let's say 315 degrees. When we will reach here in the midway, United Kingdoms, we are facing like this. This is the North Pole. We are approximately 90 degrees from it. So it will show that our heading is 270. Similarly, when we reach Washington, like this is the North Pole, our heading has again changed. So this is one thing to know about Great Circle. Even though it's a straight line, but if we are taking a compass with us, which is always pointing towards the North Pole, it will automatically change the heading because we will have to cater for the compass's turn. The Great Circle will not say that if we are taking a compass, then it will always point in the same direction, let's say 90 degrees. So it does not mean we will always travel 90 degrees and we will reach a point. No, the compass heading may change, but our path is straight. This is one thing to remember about it, and we have discussed about all the important points about Great Circle, and we could proceed now to the Rhumb Line. Please note it down. So let's start with the next topic, the last topic for this video, the Rhumb Line. Its definition says it is a line which cuts all the meridians at an equal angle. So let's first write down the definition, then we'll understand each term in it. Now, why do we care if the line is cutting the meridian at equal or unequal angle? Why do we care about it? So the reason is, first, meridian at an angle. Whenever we cut some meridian at any angle, it becomes our true heading. Let's say we are cutting a meridian at 090 angle. That means our heading is 090, our heading is eastwards. Similarly, if we cut it at 270 angle, that means our heading is westwards. That's why we care. Now, if a line is cutting all the meridians on Earth at an equal angle, it means the heading, the true heading that we'll get on that line, will remain constant all around the Earth on this line. That is the significance. Let's understand it while drawing it on a globe. So this, I've made an example. All the parallels of latitude, 45 degree north, 30 degree north, 0 degree north, the equator, all of these are Rhumb lines. Why? Because it's cutting all the meridians at 90 degree. Our heading will always remain 90 degree as long as we are on that parallel of latitude. That's the significance. But this is not the only way to draw a rhumb line. There is one more way, like this. You see this dashed line spiraling towards the pole? This is also a rhumb line. We took the initial heading at 080, let's say, and because the heading was not 090, instead it was 080, it made the line climb a bit. थोड़ा सा ऊपर आ गया नेक्स्ट लाइन, सिमिलरली थोड़ा और आगे गए, थोड़ा और ऊपर आ गया, इसी वजह से ये स्पाइरल होते होते पोल्स तक पहुंच जाएगा. So if a rhumb line is not 090 or 270 headed like parallels of latitude, it will always spiral up towards the nearest pole. If it's in southern hemisphere, then it will spiral down towards the nearest pole. This is the basic understanding of how a rhumb line looks around the globe. The next topic, which is departure, the entire topic is based on this rhumb line only. Basically, mostly 090 and 270. So now let's write down the properties of rhumb line and then we'll understand those properties. Okay, so for first two are we've already discussed it with the globe. First, constant heading. When on a rhumb line, our aircraft will always be on constant heading because the definition of the rhumb line already said that it cuts equal angle with the meridians. Second, it spirals up towards the pole as we saw on the globe. This line is spiraling up towards the pole, except if the heading is 090 or 270. Means except we are traveling on a parallel of latitude 090 270, in every other case it will always spiral up. The last one, it is not the shortest distance between any 2 points except equator. So again, rhumb line gives a constant heading, not the smallest distance. And opposite happens in great circle, as we already studied. Great circle gives the shortest distance, not the constant direction. So exactly opposite, but except on equator. Why? Because if we see this equator, it is both rhumb line and great circle. Rhumb line's definition, cutting all the meridians at equal angle, equator follows it. Great circle definition, divides Earth into two equal halves, follows it. So because the equator follows both rules of rhumb line and great circle, it is both a rhumb line and great circle. That's why this exception is there. So this is the basic understanding of all the properties of rhumb line. And here only we will end this video. You could pause it up and write it down. In the next video, we will start departure in complete detail, also solving all the important questions of it. So see you in the next video. Jai Hind.